Hey everybody, let's spend a little bit of time going over some sample problems out of Brown-Lemay Burston. And so this is question 21.13. And so it says write balanced nuclear equation for whatever process it is. Okay, so here we have rubidium-90. Okay, now whenever we do this, I think that it's important to keep in mind the type of radiation and which side of the reaction it's going to be on. Then afterwards, we have to keep in mind that when we balance these, it's going to be the balancing using atomic number and mass number. Those things need to be equal. Okay, so excuse me. So let's do rubidium-90, Rb, and when we write a reaction, we want to write the we want to make sure that the reactants are on one side, on this side, rubidium, and then 90. And then it's undergoing beta emission. So when we do that, beta emission means that it's being given off as a product in the reaction. It's going to be written on the right-hand side of the equation. Plus, and now we have to figure out what it breaks down to. So all of these things have to add up. So 0 plus what gives us 90. This is going to be 90. But now -1 plus what gives us 37. Well, this should be 38. So the thing that undergoes beta emission, when I look it up, is going to be strontium. SR, we look up element number 38 on the periodic table, and that's strontium. Okay. Now, selenium-72. So selenium has an element symbol of Se, and it has an atomic number of 34. Okay, and so its mass number is 72. That's what that number is, and it undergoes electron capture. So electron capture means that the electron is going to be on this side of the equation. Now, keep it. This is what I always say about the understanding the symbols. Here, even though beta emission is emitting an electron, that is a radioactive process. Here, we're saying it's capturing an electron, and so that's kind of the difference, is that electron can be coming from anywhere. We're not saying that it has to come from someplace specific, but this thing is being captured by the nucleus, okay? And so when we do this reacts to form something. And so notice that this is on the left-hand side of the equation now as an electron, okay? And so it's capturing, it's taking in the electron. And so now we do the same thing that we did. We know that it's going to be 72. This has to add up to this side, 72. And then 34 plus a -1 is 33. And so we look at element number 33, and that's arsenic. Okay. Now, part C says krypton 76. So that's Kr, and it's 76, because that's the mass number here. And krypton 76, krypton has an atomic number of 36, okay, and it's undergoing positron emission. So emission means that the positron is on this side of the equation, and remember, positron is an anti-electron, okay, but we use beta because it's a radioactive decay. It's something that's being given off through radioactive decay, okay, and so then what does this form? Well, +1 plus, I think it has to be a 35, right? +1, and then the 0, that makes this 76, so 35, this is going to be bromine, okay? Now the last one is radium, oh, excuse me, okay, D, radium-226, Ra, and then 226 here, let's see, radium is element number 88, and its mass is 226. Again, that's what that number is. And it's emitting alpha radiation. So again, alpha radiation is this. Okay, it's the same as a helium nucleus. And I sound like a broken record, I know, through this whole video, but again, we use the alpha because it's implying, it's the context, right? We're doing this as a as a radioactive decay, as a radioactive process. Okay, so then this is 222, because 222 plus 4 is 226, and then this has to be 86. So we look up what 86 is, and 86 is radon. Okay, so I hope this helps you out, and have a great day.